So what we're going to do over the next hour and a half or so is to run through all the elements and building blocks of BIM as such, and see where all the dots joined up and how we colour in some of those boxes. So when you type in BIM into Google, what do you get? You get lots of things. You get an awful lot of answers, and most of them contain some of these words, whether it's entities, elements, BIM, PIM, aims, data drops, complexes, facilities, uniclass, Cobie, whatever it might be. So I took a poll of all the words and said, right, we need to explain all these things and show you how they all link together. But let's start right at the very, very beginning. Who can tell me what happened? No prizes for those who've sat through part of this presentation already. Who can tell me what happened in 2008 to 2009? Something really pretty bloody significant for the UK and for the world, really. Go on, hazard a guess. I'm not going to continue the presentation until somebody gives me an answer. All right, that's it, I'm off. That's where we end. Come on. A financial crash, that's it. The financial crash happened. One of the reports that came out of that financial crash was an Options for Growth report that said 7% of the GDP of the UK is spent on construction, and 40% of that 7% is government funded construction. That's a hell of a lot of money that we spend every year on government funded construction. My money, your money, taxpayers' money. And what we want to do is we want to improve that and also drive down the cost of not only procuring but also running, owning and operating those assets. So in May 2011, the government published a construction strategy that required that all projects required collaborative 3D BIM on all project asset information, documentation and data being electronic by 2016. Who's read this document? Wasn't it dull? Hell yes. How many times did you fall asleep, Henry? However, one or two little nuggets of really good stuff were in here, buried amongst the God knows how many pages there were, but there were quite a few pages. So it's a good report, well worthwhile. And this is sort of the watershed that told us that we needed to do things differently. One of the other documents that came out was the government soft landings. Now, they identified a need to improve what we were delivering and also how we procured our assets in the public sector. Now, to do that, we needed to initially make sure that there was an early engagement of the end user. Now, that's the people who commute on that train or drive on that motorway or use this building or get sent to prison and use that cell. Okay, we need to improve their engagement with that particular asset, their experience with that asset, and so early engagement of the end user was very, very important to ensure that we're delivering something that's fit for purpose. Every project needed a GSL champion, government soft landings champion, a BIM champion, a BIM coordinator as such at every level. So that's not just the client and the tier one contractor, but every single one of you, if you're working on a BIM project, needs to have somebody who has that in their mind. I am the GSL champion for this project, and I'm going to take responsibility for ensuring that whatever is required is delivered. There were three clear targets. Targets for social outcomes, to ensure that the building or whatever we're creating impacted correctly socially on the people and the environment around it. Economic outcomes, to ensure that we drove down the cost of not only construction but also owning and operating the asset, and environmental outcomes to reduce the impact of whatever we are building on the environment around it, to ensure that we understood the carbon and also other impacts in that area. We wanted to make sure people focused on commissioning, handover and training partnerships. In the past, we're very, very good as an industry in delivering a physical asset. That's great. We've been building things for thousands of years. Wonderful. what we haven't been really good at is handing that over and then training the end user. This is what I want you to use. This is how I want you to use this asset in the future. This is how we can get better social, economic and environmental outcomes if you use your asset this way. So having that partnership is very important. And finally, requiring a post-occupancy evaluation for 3 years. So once something's complete, for 3 years after that, it needs to be monitored, it needs to be evaluated, and the impacts that we've had on those 3 targets needs to be recorded and find out if you've met those targets. If you haven't met the targets, at the moment there are no contractual clauses or commercial problems to say you didn't meet the targets, right, I want some money back. I think that probably will happen in the future, but at the moment it's a case of, right, well, we know what went wrong, let's correct that and make it better in the future. So the GSL identified a way, instead of delivering information in a big bang, they wanted it in a steady drip, steady communications backwards and forwards between all the partners within the project. And they identified data drops, which I'm probably sure you've all seen in all the presentation or documentation you've read, green footballs. This diagram here is a diagram courtesy of Phil Jackson. We call it the downward curve because he wanted a name for his diagram and he was tired of Mark Bew and Merv Richards getting their wedge diagram in every BIM presentation. You'll be pleased to know that I don't use it because I think we're past that now. We don't need to see a wedge on every bloody presentation we have. So what does it describe? Well, it describes the OPEX and the CAPEX side of a project. It describes the drops of information through that and the build-up of information over that life cycle. So we start, as most of the assets within the UK do, operations. There aren't that many greenfield projects out there. Most of us start with an existing railway, existing motorway network, existing building, prison, school, whatever it might be, and create major and minor projects on that. We go through maintenance. So this is the information required to maintain and operate our asset, which is in our Maxima or our LIP systems or whatever it might be that we're using. And out of that forms a strategy to say that at this moment in time, it's no longer cost effective to operate and maintain this particular asset. We need to either replace it, upgrade it, whatever it might be. So that strategy comes through. And this is the information we require to make that strategy. The next one is a brief. This is the information the client, after he's made his strategy, says, right, this is the information I want to pass down to you as the contractor. This is what I want. I want you to build a railway between A and B. It needs to ship 20,000 passengers per hour. It needs to run 24 trains every, however long it is, every 2 hours down a section or whatever it might be. And this is all the information I have currently for that particular asset. So that's what I will explain a little bit furthermore later on is Cobie. So I'll hand you a file that contains all the asset information of what I've already got. And it will contain all the drawings, all the documents, all the other things that they already know, perhaps a laser scan, point cloud survey, whatever it might be. But that's the brief. That's me, the client, telling you, the contractor, this is what I want and this is what I already have. Concept. That's you, the contractor, telling me, the client, this is what I'm going to build you, or these are the options you've got. So this actually is a 3.1, 3.2, 3.3, 3.4, whatever, however many options you've got. One has this much carbon, one has this much environmental impact, one has this much cost, etc., etc. Okay, so that information is you back to me saying, I understand your brief, this is what I think we're going to do. Then we go through the design. So that's you back to me again saying, well, great, you've engaged me to do the design work. This is the detail of how it should be built and how we're going to move forward into the future. We go into the build and commission. This is information that's actually from the lead contractor down the supply chain, down to the temporary works guys to say, look, this is what I want. This is how I want you to build it. This is the information I want you to give to me. And we'll cover those employers' information requirements in a little while. And then finally, we have the handover and closer. So that's the information back from the supply chain all the way back up through the tier 1 contractor who collects that in their project information model and then pushes that back up to the client and the owners and the operators. And then finally, we have end of life. So all that information you've got here helps me at the point to say, well, actually, this asset is no longer financially, environmentally, or socially viable, so therefore we need to decommission it, and we now have the information to do that, when to do it, and how to do it. So, important diagram. Has anybody seen this one before? I'm pretty sure, yes. Matt, Lewis, a few of the people in the room should have seen this diagram before. It appears in, I think it's PAS Part 3. Yeah, indeed. So, an important one. So, right at the very top, we've got organisation information requirements. These are the information that I need to run my business or on my organisation. So, if it's a rail, I need to know how many people I need to transport in how many places, how many stations I have, what is my end game for the end of the year, how much profit I want to make, all that wonderful stuff. And from that, I need to know what information I require about my assets to meet my organisation information requirements and my goals at the end of the day. This is the big problem out there at the moment. A lot of organisations have this sort of information, but they haven't organised it and they haven't brought it together into a single asset information requirements or a data dictionary as such. So this is all the things I need to know how to run my particular asset, right down to elements level. So if I've got a filter in the ceiling that I need to change, the information in here needs to tell me where to isolate that filter before I change it. Where do I go to get that bit of kit to change that filter? How often should I check it, etc., etc., etc. So it's all that information that I need within a dictionary. And I'll come to that a little bit later on because there's a problem here, a big problem. That AIR specifies our asset information model. Now, when I say model for everybody in the room, what does it conjure up? Pretty 3D picture? I'm afraid most technology vendors have sold you that thought over the last 10 years or so. It's not right. Model is a data model. Yeah, that is everything you know about the assets. That is metadata, that is documents, that is drawings and models, yes, but it's everything that you need to know about that asset. We're finding currently at the moment that only 18 to 20% of this information is CAD. The other 80% is your GIS, it is your documents, it is your metadata and everything else that you desperately need to know to run your organisation and your assets. So I'm glad there are a few people in the room that understood the 3D model bit because that's a really big, terrible culture thing that's been foisted on the industry for many years. So all this defines EIRs, Employees Information Requirements. Now, this is the information you need to know to deliver your asset at the end, and what information the client needs to know to run that asset in the end. So this contains things like the asset data dictionary. It contains things like the classification system you should be using. It contains what common data environment you should be using, what types of files they want. It contains what processes, standards you need to achieve to get to that level. It contains everything. And the more strict you are in your EIR, the better. If I asked everybody in the room to construct a sentence with the word BOW in it, what instantly springs to mind? Could be anything. So it could be an elbow, could be a bow, could be a bow, could be a bow of a ship, could be a bow at the start of a play, it could be anything. And unless you're very specific about what you mean by BOW, you're going to get 20 different answers. And the problem is when you've got a complex engineering environment and you give something that's woolly out to all your contractors, they come back with 20 different things. And well, actually, I confirmed and conformed with your contract. That's not a problem. Oh, yes, you did, but it wasn't quite what I was looking for. Well, if you want me to do something different, you're going to have to pay me some more money. EIRs are not just the client talking to the main contractor. That's the main contractor talking to their supply chains as well. Each level has an EIR, so everybody understands this is the information requirements that I have to push back up the line. This is when I have to do it. This is the assurances and the workflows that I have to go through to deliver that information. So everyone needs an EIR. These EIRs are tested by plain language questions. They've always been a little bit contentious over the years because these kind of questions can be at quite a few different levels. And we've all been very used to answering those level questions right at the very top. You know, how much carbon is in here? That's my plain level question to somebody about a car or whatever it might be. But actually, the real PLQs, the ones that allow you to run the asset in the end, are the ones like, where do I isolate this circuit to change that filter? That's what the maintenance guy needs to do. He's going to be maintaining and operating that asset for the next 150, well, he not personally for 150 years, although I've got to say in Transport for London and London Underground, some of those employees do look around about 150 years old with a few attitudes to match. But having said that, nobody's really asked the maintenance and the operations guys what they need to know yet. And that's why this has always been a bit of a problem. We've all been very good at delivering information. Oh, it's this high, this wide, this deep, and it's painted this lovely colour. I couldn't give a damn. I want to know how to isolate it and what oil I put in it every time I need to maintain it. That's the really important information. So you test the EIRs by the PLQs. These plain language questions, if you can't answer these using this and this, then you're not doing it right. So all that wonderful stuff really is in the client's domain. But most contractors will help clients write EIRs, and they'll also help them test it by the PLQs, because the chances are most of you own arms within your company that do maintenance and operations on the railways, the highways, or whatever it might be. So this is the contract line here on the right hand side, this blue line. So as information passes out of the client and into the tier 1 contractor, it's a data drop. This is my brief that says, I want you to build this. This is all the data that's come from here, from here, from here, into the project information model. And once again, when I say model, I mean data model, not pretty 3D pictures. So, tier 1 contractor builds up their project information model, and that is fed by across other contract lines within here. My apologies for not putting everybody in here, but it could go on for a very, very, very large diagram. So information is pushed up into the PIM. And then every time we get to the concept, to the details, the construction, the handover, operation, maintenance, etc., data drops are pushed out into the asset information model to allow the organisation to make decisions and get better outcomes for their assets. Any questions on that? Oh, dead silent. Right, so government understands that there are a lot of problems there. A lot of people don't understand quite what they're doing. They need help. So they set up the BIM Transcript. All right, cracking set of people to help you out. They put a website together. It was taken down about 2-3 weeks ago, and it should be back up again now. I don't know whether anybody's been into it in the last week. Okay, because they're restructuring and redesigning it. But what the website BIM Transcript does, it's all about putting the building blocks together to help people achieve that level 2 by 2016. One of the areas that you need to go into there, I'm not sure if the new website has it or not, is the BIM Transcript Labs. When it was up and running, who's been in here? Okay, a few of you. Right, it's important. It's got lots of information. If you don't comply to a lot of this within here by 2016, life gets a little bit difficult. So on the BIM Transcript in the labs area, there was a document called the Digital Plan of Works. This came out in March 2013. There is a new one which comes out at the end of this month. I've seen a few of the pre-release drafts, and there's some really good stuff in it. If there's one document that you need to read, it'll be this one when it gets launched at the end of the end of the month, beginning of next month, or could be the following month, or could be the following month. You know how these government groups go. We like to extend our release deadlines as and when we want. But the Digital Plan of Works sets out the concepts and the detail to achieve building information modelling, or building information management, as it should be, and the Digital Built Britain, which is the new strapline going on to the end of the BIM acronym instead. So well worthwhile downloading it when it comes out and reading it. Who read the original? Yeah. Let's get back to that asset life cycle. That was the Phil Jackson downward curve, but Andrew Wolstenholme puts it a little bit more simply, and he shows us the impact of BIM on the various phases of the life cycle of an asset. So down the design and construction side, the impacts are less, but our industry as a whole sees this side a hell of a lot larger. BIM has always been very much at this end of the world, always been very left field, rather than where the bigger business outcomes are, which is the operations and maintenance side. Nobody talks to the maintenance guys. Why don't we talk to them? Because most of the time they're in a basement somewhere, behind a locked door, kept out the light, fed on whatever we feed them through the door. We don't treat them as equals, as good engineers a lot of the time, okay? But they are really, really important when we come to run, own and operate our assets. So it's their goal was, by the end of the Parliament, by the end of the government, was to reduce costs by 20%. Have we got there? Realistically, probably not, because I don't think any project has actually got into this bit yet, where they've been using true BIM principles. So time will tell. By the end of the next, well, I'll have been retired a long time by then, 2025, they're hoping to save 50% within here. So, and I can see that their maths is good, but we need to see it actually happening rather than an academic putting some numbers on paper. So let's talk about assets. What do we mean by an asset? Well, an asset is a physical thing that delivers a service or a supporting service. So to us, an asset is a bridge, is a manhole, it's a bit of blacktop, is a safety barrier. We take that down to the maintainable level. So we're not talking about all the bolts, the nuts, the plates within that safety barrier. We're not talking about the hinges and the panes of glass and whatever within that window. The pump, we're not talking about the motors and bearings within that. We're taking it down to the maintainable level. The bridge example is a functional grouping. It has a function. The bridge takes road A over road B. It is an asset in its own right, but it has lots of assets within inside it. It has piles, they're individual assets, beams, deckings, piers, surface courses, retaining walls, safety barriers, all individual assets, but they come together to make up that functional grouping. And we need to identify all these assets wherever we are. So we put it into a hierarchy. At the very top, in this example, we have a complex. Okay, this is all the highways in Highways England, as they're now called. Below that, we have facilities. Now, facilities are hubs and connectors. So the M1 is a facility, and Junction 29 is a facility. So hubs and connectors. If you think of the waterways, you've got piping and rivers between pumping stations and filters and dams and whatever. They're all facilities in their own right. If you think of railway, you've got railway stations and the lines going between them. With power, you've got power stations and the lines going between them. If you're just taking down to a pumping facility itself, the facility could be the room, all right? But it is a hub or a connector. Along that facility, we have lots of entities. Those entities are things like earthworks, So the structures, they're the blacktop itself, it's the drainage, it's the gantry systems, it's all the things that go along that facility or inside that facility that make up the entity. So, and then the entity is made up of lots of elements. So right at the very bottom, we have a safety barrier element, which is part of a bridge entity, which is part of a junction facility, which is part of the complex with the Highways England. It's a really simple way of structuring the assets. And that brings them together in functional groupings. So each of those assets, all the way down from facility, entity, and element level, need to be identified. So within our documents, our drawings, within our point clouds, our models, the physical asset itself, our forms, or whatever it might be, we need to identify absolutely everything and make sure it's a unique identifier. Now, the Crossrail organisation have a wonderful asset tagging system. You see them up here. They put in a location, a function, classification, and a number. That's lovely, but you don't have to do that. As long as it's a unique identifier, it is fine, not a problem, because you're all going to work on systems that are going to need different naming conventions. But the point is about the asset tag is it's just a duty of an object. It carries out a specific function. So within your models, within your drawings, documents, whatever it might be, you have an asset tag which talks about functionality. Not the equipment itself that carries out that functionality, but the functionality itself. And the reason this is important is when we replace, let's say the tag is something that needs to project or present PowerPoints on. It's this telly. Okay, the equipment is this television. But in 10 years' time, I'm going to replace this. What I don't want to do is go through all the 3D models, all the documents, all the drawings, all the asset databases and everything, and replace the equipment on all of those. What I'm going to do that is I'm going to replace the equipment that fulfills that functionality in the asset register, and that's it. All the other ones, the asset tag stays the same because the duty, the function I require, stays the same. Okay? So the asset tag is the specific duty of an asset. Then we have the equipment that carries out the duty. That might have a serial number. And that asset tag might actually be many assets that create a functional. So that's the bridge, which has its own tag, and then you've got the piers, the decks, the piles, the whatever it is, the wing walls within there. So in the Crossrail world, pinch with pride, I call it. I pinch their slide completely because I like their concept and how they've done it. So it's a Crossrail setup on here. But in the physical world, you have your labels. In the virtual world, you have your tags with the equipment in the asset register. Now, to imagine this in a slightly more, slightly easier way, if I've got a drainage system here, it's got a pump sitting on a plinth, it's got a filter, it's got some piping, it's got a valve and whatever within that system. That plinth has a white label on it that says, I need a 500 watt pump here. The pump itself has a yellow label on it that says, I am a 500 watt pump and I can carry out that functionality. Yeah. So when someone comes along and steals my pump and takes it elsewhere, I still know what needs to be in this place to carry out that particular duty. And also when I upgrade it later on, when the pump breaks, I don't have to go through all the documentation, everything else, replacing equipment serial numbers or whatever it might be. I just replace it once in the asset register. The functionality stays the same. Pretty simple stuff. You don't even have to label bloody everything. That's just an example. Things like a concrete floor slab or a pile, you probably don't want to label. What you might want to do, however, is drop something like an RFID tag into a pile cap, because in 150 years or 50 years time when the building is demolished, repiling or finding out what the pile is actually capable of is very difficult. If you can identify that pile, then you can reuse it. One of the biggest carbon footprint problems of reusing a building is if I don't know what that pile is capable of, I've got to put a new pile next to it or drill it out or whatever it might be. So just being able to identify something like that is pretty cool. Incidentally, that's quite an interesting tag. It's it's not actually a ball cock for a toilet, which a lot of people go, what the bloody hell are you walking around with a ball cock for a toilet? But you can drop it in concrete. It can be read through 4 meters of earth and reinforced concrete. It's got a 150-year shelf life. It's a passive tag, and the reason it's in a ball cock is because the antenna always points upwards. So I know that it's there, or over there, or over here. What a clever piece of kit. But they're pennies nowadays when you do that. So, tagging elements and entities within your drawings, models, documents, whatever it might be, in the briefing phase and the concept phase. I know there's going to be a bridge there, but I've got no idea how you make the bridge up. So therefore, I'm tagging at entity level. Yeah. And then when I go into the detailed design phase and construction phase, I am tagging at element level, because I know there's going to be a pile there, or a safety barrier there, or whatever it might be. Then we get further into the construction side. I know what equipment is going to be carrying out that functionality. So in the asset register, I write all the information about the equipment that's going to carry out that functionality. So for those of you who were there at the TWF meeting back in, when was it? December last year, you'll recognise this slide, or chances are actually you're probably asleep by then. So anyway, how about temporary works? How do I think we should do temporary works? Now this is only my opinion. All right, this is my own personal opinion on this. Today, later on, I want us to actually get into that discussions and decide, potentially, or put a white paper together, how are we going to do temporary works within BIM, and how we want to move things forward using the principles that we've got here at the very beginning. My own personal thought is that we don't want to be tagging, we don't want to be drawing every single bloody piece of scaffolding or hoarding or everything like that, because it's a waste of time, waste of money. What we can do, however, is put a box around work packages. So if I'm doing a certain, or need a certain function, which is to support some hoarding or support a particular building of a wall or a tunnel roof lining or whatever it might be, that is the function as such. So that's the box I create within my model. It's an asset tag I put on it to say this is a function I want to carry out, and within the asset register I record all the information about that particular bit of temporary works that I want to do. So what does that allow me to do? One, it allows me to interact with 4D modelling, because I now know that this area here is unavailable at this moment in time, and I need to do certain things at certain times. It allows me to use that asset register to ensure that I've got all the bits that I need for that particular work package to go on, because you'll list everything that needs to be in there. And if you don't list it in the asset register, you put a link to the document that does list everything you need to do for that particular thing. But what it would also do is allow you, if you're going to abandon it in place, is to transfer the ownership of that asset. Instead of being temporary works, it's now permanent works that you're going to have to hand over properly, that is already in the asset register, is already labelled, you've already got a spatial location for it, and it also allows you to coordinate when you're getting into a complex engineering environment, which I'll explain a little bit more later when we get into the Crossrail story. So, but that's my thoughts. Obviously, you guys are going to have different thoughts or arguments for and against, or whatever it might be. So that's what we'll look at a little bit later today. So I want to talk to you about the 8 pillars of BIM wisdom. Now, with the impending delivery of the digital planner works, this might change a little bit, but until we actually get the final signed and sealed document, I'm not going to change what I'm saying yet. This last pillar here actually contains an awful lot of information that is added to and removed as we've gone down the last 2 years, but the rest of them are pretty solid. So what are they? Well, I'll give you the BS's first of all. First one is BS 7000. Anybody know what BS 7000 is? Looking at Lewis there, because he knows definitely what BS 7000 is. It's all right, I won't ask you. BS 1192 2007, PAS Part 2, PAS Part 3, BS Part 4, PAS Part 5, GSL, and 8541. This means absolutely bugger all to most people. And when I talk to people in the elsewhere in the world, it doesn't mean anything at all because they have their own standards that will go against it. So in English, what does that mean? Well, we have a standard for collaboration, making sure people cooperate, collaborate, coordinate, and communicate. We have a standard for CAD and model management. We have a standard for CapEx information management. We have one for OpEx information management. We have one for information exchange, making sure that we all speak the same language. We have one for information security, which scared the willies out of a lot of people last year, and I'll talk a little bit more about that later. We have one for better outcomes to ensure we get those three good things: the social, the environmental, and the economic outcomes. And finally, we have one that covers a multitude of sins, which is the information definition standards. So, BS 7000. Right, so this is all about collaborative working, influence new technologies, the effect of construction procurement, your aim, your main objective, what you want to achieve, and the roles and responsibilities at the back end. Now, I picked this particular picture because it's not quite my background, but it's getting very close. I'm very pleased that I wasn't part of this particular picture. Can anybody tell me who these guys are? Bravo 20. There's the lunatics in Iraq. I look at this as being very much along the military background because in a section, in a team, we know each other's roles and responsibilities. We can take those over if required at any moment in time. We know the effects of our technologies. We know the effects of our weapon systems, of our radio systems, and everything else. We know how to work together as a team, collaborative working, and we also know what we want to achieve. What's the effect? What's our aim? What do we want to do at the end of it? The problem with these guys, of course, is they were a pretty dysfunctional bunch. They didn't collaborate, they didn't talk to each other, they didn't communicate very well. They didn't understand each other's roles and responsibilities. There was two leaders that were trying to vie for each other's taking over. They didn't have good understanding of their technologies. Their radio systems didn't work. Emergency attack beacons didn't work. They didn't take the right cold weather equipment with them, etc., etc., etc. And they didn't have a clear aim. They weren't given a clear mission at the very beginning. So what happens? It all falls apart. So there are always very, very clear parallels, I feel, between construction and the military way of working. So BS 7000 talks about collaboration, cooperation, coordination, and communication. 11/92/2007. What's significant about the date? Go on. Pre-recession. Pre the financial crash, 2008-2009. The standard came out of something called the Avanti standard. Who's heard of the Avanti standard? So yeah, quite a few people in the room. The Avanti standard was used on the Victoria Station upgrade project right at the very beginning to allow for information to flow freely and be structured correctly between TfL and Mott McDonald's as the client. What was really nice about that project was the client really knew what they were asking. They had really strong EIRs and good strong leadership to go with it. So it's been quite a good project. But anyway, they used Avanti and eventually went into BS 11/92/2007. And when the construction strategy report came out and the BIM requirements came out, they said, well, we need a good, mature standard to help us control information within design and construction. And that's why they picked the BS 11/92/2007 document. So for those who have used it before, this is all old hat, but these four boxes are the key processes or the key stages of pushing information. So right at the very beginning, work in progress. That's the only place your information is ever amended. That's it. That's where all the drawing is done. That's where all the modelling is done. That's where all your documentation is written, whatever it might be. That's where it's always amended. Shared area, once it's gone through an approval process, is an area where we share each other's information. Now, if you don't share things using the correct formats, the correct processes, the correct standards, and all those kind of things, you're not going to get a very good shared environment because you expect somebody to give you information at the right time, right quality, the right format, so you don't have to do any sort of fiddling around to get it into your environment. Now, when we start talking about that, we start talking about things like IFCs. Now, this is not issued for construction, so most people would understand that terminology, but industry foundation classes. Who's come across those? Okay. Are they fit for purpose? Not yet. No. Will they be in my lifetime? Yeah.
Very optimistic.
It's very optimistic. I like the optimism here. Very, very good. And also the optimism of the Thames Tideway project. The deliverables, contractual deliverables for Thames Tideway is Cobie and IFC. So they're betting on both of them being capable of delivering what they want to do by the time their deliverables are required. I'm not a gambling man, but I wouldn't put my wages on that. Thank you very much. But anyway, so shared area where information needs to be of a good quality. Now, when that's delivered to the client or delivered to wherever it needs to be delivered to across that contract line, those data drops, it's published information. Okay. So what's this fourth box for? Well, this fourth box is all the information that's generated during the project which isn't necessary for operations and maintenance. So let's all of the wonderful 4D and 5D modelling you've done. It's very nice, but actually running the railway, I couldn't give a damn about any of that. It's just a pretty picture. However, when I decommission that thing, or when I commission a new major or minor project on that area, what I will do is I will take that information out of the archive, give it to the contractor and say, for your information, this is fit for information. You can use it, but it's not been maintained over the last 50 years or whatever it might be. So this is information that's maintained. This is information that has been archived and is there for information only once you have delivered the asset. So, BS 1192-2007. Then we have PAS 1192 Part 2, which is the CapEx side, the requirements for achieving building information modelling level 2. We have PAS Part 3, which focuses on the OPEX side, the operations maintenance. Who's read both of those? Yeah, so quite a few people. How big or how much more information was in here than here? A disappointing amount, especially when you think about the life cycle of an asset. In the diagrams, within all those documents, 3/4 of the circle of life is dealt with by this, PAS Part 3. A quarter is dealt with Part 2, yet we still only focus on design and construction for most of it. This is where the savings, the big savings are, the outcomes are, this is why we're building it in the first place, and yet we still put an appallingly small amount of information and guidance into the ops and maintenance side. We wonder why we haven't engaged the maintenance guys properly. Last one in that list, BS 1192 Part 4, is dealing with information exchange. And that horrible word, Cobie. Who's come across Cobie? I know you will. So quite a few people. What was your reaction when you first opened up a Cobie file? Was it bewilderment? Yes. We're all very clever people in this room, and we all expect to open up an Excel spreadsheet and go, yeah, I can understand that, I can follow all the columns, yeah, not a problem. When we open up the Cobie file, it doesn't always have to appear in Excel format, but I think that's its biggest problem. We open up that spreadsheet and think, I can understand this, oh shit, I can't. Just, it's not fit for purpose, I won't use it, don't worry about it. Okay, so that reaction is hamstrung. If it had been just an XML file, noughts and ones, you and I would have opened it up and gone, oof, I'm not supposed to understand that, it's a Codie thing, close it down, not a worry, we'll use it later. Would have been a problem. But it is a problem because we can open it up and we think we're clever. Most of us are very clever. When you type in Cobie into Google, what do you get? You get this lovely young lady here called Cobie Smulders. Okay. She is safe for work, so it's not a problem. However, unfortunately, the government didn't engage me to look at Cobie Smulders all day. They engaged me to look at construction operations building information exchange, which was a the schema that was put together by Bill East and his team in the States for the US Army Corps of Engineers to exchange information from their construction into the operations maintenance phase. When you look at Cobie, all you need to think about is it's a suitcase. You put information into it, or your system puts information into it, and their system reads information out of it. Don't open the suitcase. Simple as that. You don't want to know what's in there. But your systems, your ellipses, your maximos, or whatever it might be, can open that up and read it. They can generate it as well at the very beginning. Your systems like the EcoSims, the Revits, the Teklas, the Rhinos, the whatever it is that's out there, they can open up Cobie and they can spit out Cobie. So don't try opening it. Just use it. All right. We call it Marmite legislation because either you love it or you hate it. Personally, I hate it. I hate it with a passion. But what is it doing? It's making us exchange information in an interoperable way. If everybody can produce a Cobie file and everybody can read a Cobie file, then instead of me trying to translate your CAD file or your spreadsheet or whatever it might be, or hunt around for information, then we've got a chance. We're not going to miss something, or we're not going to poorly interpret something when it's being handed over to each other. What I'll talk about a little bit in a little while is something else within this interoperability side of things, is the information itself. It's not down to technology. Technology doesn't have to be interoperable. Information needs to be interoperable, but we'll cover that shortly. So, PAS 1192 Part 5. Just when you thought it was safe to go back in the water, along came a smart-dressed fellow with an MP5 and an Aston Martin from the down the river, came to the ICE BIM event and scared the shit out of a lot of people because he said, "Great, you're getting all this information. It's wonderful. It's brilliant. However, what happens when the terrorist gets hold of that information? It's really easy to get hold of. You haven't put really good security on there. It's in the cloud somewhere. They can just suck that information down." Now he knows precisely which steel beams within your building you can put a small explosive charge on and bring the building down and destroy it. Or he knows exactly the ventilation shaft on that crossroll station to put the anthrax in, that he can now kill 200,000 people within minutes. Easily done. Scare the willies out of me. Okay, so we need to think about the security of that information. Not only the security of information in the big boys, in the tier 1 contractors, all the way up through to the owner operators, but all the way down the supply chain. How do you access the information at the manufacturers, the logistics, the fabricators, that end, and how secure is that data? Giving people access only to the information that they need to know. Be really interesting when that finally comes out. So far, we've been involved in some of the early read-through and dealing with the crossrail systems and also the Thames highway systems. They comply, which is quite pleasing. But there are a few members down the supply chain outside of that that are certainly open to these guys. So that last pillar, BS 8541. Who's actually read BS 8541? And why is it a bit of an oddity? Of course you had to read it, didn't you? It's the sort of the fact. So what it basically states is that you need to have a standard definition for 2D libraries, 3D libraries, coordinate systems. You need to have a similar classification system. You need to have a common way of setting out all your architectural objects or your engineering objects, and basically giving you a framework to put all the standard things that you need to create to make sure everybody's speaking the same language. Now, what actually goes into this lot, the standard itself doesn't define, doesn't tell you precisely what goes in here. What it does is it just says you need to have a classification system, you need to have a standard library, etc. And in the employer's information requirements, it will say you need to use this library. you will need to use this classification standard. You will need to use X, Y, and Z. That's why the EIR needs to be extremely clear about what it's delivering. One of those classification systems is Uniclass. Who's come across Uniclass? Yeah, it's quite a few, one or two of you in the room anyway. So Uniclass is a classification system providing a common framework for identification of an asset. So this thing here, what do we call it? Well, I call it a paper cup. Some people might call it a mug, or just a plain cup, or if it was made of glass, it might be a glass or a tumbler, or whatever it might be. If we all call things differently, there's a problem, because we need to classify things the same across the board, not only just project and project. So when two contractors start to federate their data, they understand that a beam is called a beam, and not a beam and a beam I1-4 and a beams or steel or whatever it might be, because that not only takes away the impact of bringing together federated information, but it also brings in risk when I say, right, okay, count how many beams are in that building. Right, it's 20, great, let's order 20 beams. When actually there was another 5 called steel somewhere, or where it might have been in the system. So classifying is very, very important on a project side, but also on an industry side, because we have big projects, HS2, to take for example. They go across highways land, they go across Network Rail, they go across Environment Agency land, they go across all sorts of things. And when they bring information together for that briefing at the very beginning, they need to bring together and count how many registered trees or grade 2 listed buildings or earthworks or manholes or whatever it is that they need to go through. And if they have to translate every single person's different type of information, there's risk involved. And that risk ends up becoming time, becoming money, etc. as we go forward. So when Crossrail started up, they used Uniclass 1. Wasn't fit for infrastructure. Didn't do road, didn't do rail, didn't do a lot of things. Did a lot of buildings very well, but didn't do anything else. Uniclass 2 came along. It's a vast improvement. Did a bit of light rail, did a bit of other bits and bobs, but it didn't deal with most of the infrastructure. And the structure had changed. And you'll find most people will have not gone for Uniclass 2. They'll have stuck with Uniclass 1 and carried on as a standard. Crossrail added Uniclass 1. So basically they used the structure and added all the rail and the stations, etc. within that. About, must be 7 or 8 months ago now, REBA and the MBS won a framework from the government to put together a website and a framework to hold all the common building blocks for BIM, and that's going to be part of the new website and part of the digital plan of works and everything that's coming out. But they've also been charged with gathering a framework together and the ability to put Uniclass or U3 in place. Now, this will tackle all those issues. So there should be within Uniclass classifications for everything. I can guarantee you there will not be classifications in there for temporary works, unless you guys make sure that there are. Simple as that. The BIM for water guys are really good. They don't have a government mandate, they don't have to do this, but they've got together as a team and said, we've got owners, we've got operations, we've got maintainers, we've got fabricators, logistics, you've got all the guys who deal with the water industry. It's a relatively much smaller industry than the general construction side. But they said, right, well, we need to put a common classification system together. We need a common asset data dictionary. We need to have that way of exchanging information, common libraries for all the things that go within the water industry, so we can start driving down the cost of procuring a new pumping station, etc., etc., etc. So they've taken that bull by the horns, and they're going to drive that forward and deliver the water side of Uniclass to REBA and the MBS. So my challenge to you there, that's challenge number 1, is to get a classification system for temporary works. So, part of the asset information requirements, what I just mentioned here. Asset data dictionaries. Now, a data dictionary is a dictionary that lists all the metadata required for a particular asset. So it should also list the information required at the different data drops. So what information can you expect when I give you the brief? If you know what information to expect, then the chances are you'll be able to answer that tender and that brief a lot more efficiently. Also, it'll be the data on the metadata on the detailed design. So what information should the client be gathering from you? So you know precisely which boxes to fill in on the metadata tables to give over the information back to the client. So I've met your brief. So if you know what you need to deliver, and it's common across the board, whether you're working for Network Rail, Farm Agency, Highways England, or wherever it might be, you've got a better chance of having a level playing field on all those bids. So an asset data dictionary doesn't have to come out as a document like this. What it will probably be is a big online database that defines what the asset is, says what functions and classes relate to them, gives the attributes that are relevant to them and what those attributes mean. Now it does this in certain ways. First of all, it does it in description, because we want to get over something called the IKEA syndrome. Everybody's shopped at IKEA. They've all bought something that had a depth of 300 millimeters. They've got it home and thought, depth was that way, not that way. Bugger, it's never going to fit in that alcove. So the Asset Data Dictionary describes, when we say depth, this is what we mean. And we do it in words and we do it in pictures, because we understand a good percentage of the supply chain within the UK is actually part of Europe and probably don't speak English as their first language. And depth to them means a totally different thing. So words and the pictures within there, and it gives things like how it should be labelled, what the asset tag should be made up of, a lot of definitions within that. So this is a group that I'm trying to run for BIM Transcript. There's a lot of arguments, a lot of bloodletting between the different people. The TfLs, the Network Rails, the London Undergrounds, the HS2s and the Crossrails all have different definitions for different things within their rails. The problem is they all need to have a common language because they all need to actually interface and coordinate with each other. And when you get them all into a room to describe one single thing, it ends up in a pointy match, and people storming out and whatever it might be, because they're very protective, very precious about what they've been doing over the last 150 years or so. So it's a big challenge. I need people to think about this. And this is the second challenge I have. Yes, a lot of your works are temporary and they don't go down to being permanent. But we do need to know what information do you require at the briefing phase? Do you want the client to be given at the detailed design phase, at the construction, at the handover, if something's become permanent work, and forward and onwards. So a data dictionary that gives a common metadata standard across the board for temporary works is my second challenge to you. So I came back from a trip. Unfortunately, it was a business trip. I only got a chance to spend 24 hours in Wellington in New Zealand. The rest of my week was spent travelling, which was quite a tiring one. But I went to see Wellington City Council. Actually, I went to see the Ministry of Defence out in New Zealand. It was a chance meeting with Wellington City Council in a bar that one night that I had there over a couple of pints. This guy overheard me talking about assets. He said, we've done that. I run the Wellington City Council. We do our assets. Oh, you've done it, have you? Says I. Yeah, right. Okay. Yeah, we're doing all this wonderful augmented reality and all these apps and all this mobile stuff and yeah. Okay. So how did you get the data? The data's the important. Yeah, we've done that. We've done that. Oh yeah, go on, show me. Bloody hell. Okay. It took them £10 million on 3 years. But the whole of the city, that's road, rail, power, water, dock facilities, traffic, open spaces, buildings, they have 90% reliability on all the asset information they have. They can predict when to replace something out 50 to 100 years. And know precisely what should be in their budget for the next 50 years. Jesus. I was stunned. I did actually want to drown the guy at the end of the conversation because he was a very forceful character, and you've got to be a forceful character to drive that sort of change within a local government as such. But having said that, they've achieved it. They've done what we should be doing here, and they did that by firing all their asset managers, bringing in a load of data analysts, people who could write algorithms, because they knew precisely what they needed to know for those assets. They concentrated on the critical things first. So what information did they need to maintain the asset? So they had 20 years worth of help desk queries. Every time an operations or maintenance guy phoned up and said, I need to know how to isolate this, or what oil do I have in this, or whatever it might be, they'd record it meticulously, which is pretty cool. And they'd accidentally turned on the audit trail for their ops and maintenance system that recorded every typed in query into the search database for the last 20 years as well. They wondered why they'd run out of space on their hard drive, but they had all that data, and they analysed that and came up with, these are the important things for each of these assets. This is the information that I need to know to make that critical decision on whether to replace or to maintain. So they also tied their system in with, this is not a Bentley system by the way, this is one they created themselves, so I'm not blowing our own thing, I'm just wishing we'd bloody done it 5 years ago. So they tied it in with the manufacturer and the supply chain as well. So the cost of that object, cost of that widget, cost of repairing or replacing that thing goes up in their database. So the algorithm can have triggers and whatever. They look at the required performance functionality. If that pump isn't meeting the functionality that it was required to do so in the first place, because of the flow drop or whatever it might be, it records that within that database and flags up like this needs replacing or this needs to be maintained because of the crossover of the the cost for maintenance and the cost for replacement. That functionality is very important because they do that with their traffic as well. So the junctions, the roads, they're all monitored by cameras. They can predict. Yeah, bastards. So they got on-the-go condition surveys and triggers. And so, yes, they can predict everything out for 50 years. And that's what I'd like to see us in this country be able to put money into this to create this particular thing. Because if you think about it, if you know when to replace something and how much something's going to cost next year, I can now put budget in. Let's say you're two county councils. Okay, I give you £10 million a year to maintain the roads. You get to around about March time and suddenly you replace all the signposts that you replaced last year anyway, because you need to spend the money. Because you'd only spent £3 million up until then, you spent the last £7 million just doing anything. So I've still wasted, I've still spent £20 million when I could have just spent 13. But next year, I know that you're going to need to replace X, Y, and Z, so I can give you £17 million extra. Rather than you wasting that £7 million this year and me going, well, actually, I haven't got that in the budget, you can just have 10 again. So they can predict financially all the way out 50 years what they need to have in the budget. Jesus. I want this, and I want to get this guy over to meet Boris Johnson, but I'm finding it very difficult to find anybody who will fund. Well, first of all, because most of the people who've met him want to drown him. And secondly, he doesn't use any of the software from the technology events, so there's no real benefit for us to bring him over here. But what it will be good to do is to bring him over to talk about how he's achieved it and get people going on this. Anyway, that's my soapbox for asset data dictionaries. So how does this all fit together? Well, this is Phil Jackson's downward curve, the slippery slope to retirement, although he already has retired in most cases. We've got our questions that we need to answer, which are encouraged by the government soft landings. We've got the data drops, which deliver the answers to those questions. We've got Cobie, which transports those answers to the questions. We have Uniclass, which classifies those answers, which are transported by Cobie, which answer the questions. It's like one of those songs you have at school. And then you have asset data dictionaries, which provide the details, the metadata, which are classified by Uniclass, which are transported by Cobie, which are the data drops which answer the questions. All of that is confined and controlled by the digital plan of works. We have BS 1192 2007, which deals with the design and construction information. we have PAS Part 2, which deals with CapEx. We have Part 3, which deals with OpEx. We have Part 4, which deals with information exchange. And we have Part 5, which deals with security of all of that. So where are we? Well, Uniclass is underway, but you need to get classifications in there for temporary works. Information exchange, Cobie is there, even though it's probably going to disappear at level 3, because people won't need to exchange information like this. People's systems will just talk to each other direct. Okay, but Cobie is there and it's capable of dealing now with linear assets, areas along a linear, points along a linear. Government soft landings document's been out since a long time. BS 1192 2007 is there. PAS Part 2 is there. PAS Part 3 is there. PAS Part 5 BIS, as it will be. Security is there. What's the last tick that just suddenly appeared? Ah, yes, Digital Plan of Works is underway. There's a reflection on the screen. The only thing we don't have is a common language, a metadata to speak to each other. Everybody says, well, my software isn't interoperable with his software. I can give a damn about software. If the information is interoperable, if we're all talking the same metadata for the same object across the board, my software doesn't need to be compatible with your software. All we're doing is exchanging information. And if we're all talking the same language, same classification, talking the same metadata, then interoperability becomes a hell of a lot easier. Are we going to get interoperability between people's software in the next 50 years? No, it's not going to happen. Realistically, no. Information interoperability, yes, that's where we need to go. So, we'll be pleased to know we are coming into the downward slope into the end of the presentation, so you can have a bit of caffeine and a breather in a bit. Modelling. So, taking this diagram again, right at the very beginning, briefing and concept phases, we model in 2D and we model in 3D. A lot of modelling is done in 2D because it's easy, and we don't need, economically, to do 3D sometimes during the briefing and the concept. During the design phase, we should model in 3D, and currently at the moment we extract in 2D. When we were working on the Crossrail project, a lot of the modelling that came out of the design phase was pretty piss poor. Why? Because the contract deliverables were 2D extractions. And when you've got a wonderful 3D model and you extract here and you extract here, what do you do in the middle? You don't bother to join that particular steel up with that particular pad or finish off that slab or whatever it might be. So the modelling was very, very poor indeed. That will change over time, and instead of having to extract out and deliver 2D, the deliverables will be 3D models. And we'll talk a little bit about the problems with that on the next slide. Then in Builder Commission, we have 4D and 5D, which is obviously time and cost. And then we have 6D for our asset information at the end. So as an example, take this wall over here on your right. In the 3D phase, in the design phase, I've got 12 panels and they're painted blue. Lovely. Okay. 4D, I'm now adding a time element, so which sequence do I have to put them together in, put them on the wall. 5D, I'm adding all the temporary works, fixtures and fittings, etc. So I've got a good cost over that. When I get to 6D, I maintain that wall as one asset. So there's just one single block in my model with an asset tag on it that says the functionality of this wall. As simple as that. Why do I want to keep it lightweight? Why do I want to keep it simple? Data is for databases. I don't keep data in models. So nice and lightweight, and the 6D model contains down to the maintainable level. So the other challenge as such for you is modelling. How detailed do you really need to get with temporary works? I don't know, I'm not a temporary works expert, that's down to you. But I suggest some sort of guidelines are constructed, because obviously 3D modelling is going to be the way things are going, and you're going to get a 3D model or be able to have access to a 3D model within your a supply chain that says we need temporary works here, or we need to have something to support this, or whatever it might be, you're going to need to know how much level of detail do you bother putting into that compared to how much level of detail is actually required. What I wouldn't want you to do is to waste a lot of time, a lot of effort, a lot of money producing a beautiful, pretty picture, which quite frankly is by all use to anybody. Looks nice, but it's got no function. So, final one out of this is Construction Industry Council Best Practice for PI Insurance. When I'm handing over a model, a 3D, a 4D, whatever it is, all the way up the supply chain, suddenly when I was at the very beginning just doing a 3D model, doing 2D extractions, it didn't matter too much. But now I'm handing that model over to the next guy, the construction, who might actually use that as a basis for his model to hand it over to the operations and maintenance at the end. Hang on a minute, suddenly I am liable because it's my information, it's my 3D model that they're using now to operate and maintain that. So if there's any mistakes in there, where did it come from? Well, it came from him. Oh yeah, part of the contractual deliverables were that 3D model, right? Okay, it's his responsibility. So I now need to have insurance against that. The part wasn't particularly necessary for the 3D model, but the Construction Industry Council gives us a best practice for that insurance. Now, when we're talking about insurance, we need to think about the bigger picture, something that's not really clear in what the government words about BIM. If you know precisely what you've got in your asset and you can assure all the information is correct and of good quality, the insurance for owning that asset goes down. The insurance for owning Crossrail or a prison or a hospital is huge. The insurance premiums. If I can drive those insurance premiums down, I'm not just talking about the savings we're making in design, construction, operations, maintenance. What I'm also doing is driving down the economic cost of owning that asset in the insurance world as well. So, very end of that, we always ask the question, what is BIM? Actually, you won't be able to answer that because every single one of you will have a different answer, as you did with bow, whatever it might have been. But the key thing is, everybody in the supply chain, down to the fabricators, the manufacturers, the logistics guys, the tier 1s, tier 2s, tier 3s, the owners, the operators, everybody involved in that project has got a bit of information which is a vital piece of that puzzle. If they don't give over the information at the right time, the right quality, the right quantity, in the right way through the common data environment, it ain't going to work. You ain't going to build your puzzle up and you're going to get one piece that's always missing from the sky within a puzzle. And that is that.